Hi, this is Tag, and today I'm going to talk a bit about how I like to run my Rampage Extremes and how to make them clock better. Let's start with basically a Rampage Extreme as they come out of the box. Well, not completely, but this is the closest I could find in my collection that I didn't already mod different things on, and you can see air heatsinks, original like heat pipe heatsink, stock Northbridge heatsink, memory VRM heatsink. Now, I can just talk about a few points that are universal to these things on this stock board before I start with anything else. Always run your memory in the white slots, the blue ones clockwise, significantly. Also, at high FSBs, run your video card at the bottom PCIe slot, or if you want to go really hardcore, just use PCI video card, because the top slots might drop out. It's dependent on the board itself, above like 620, 640-ish FSB. Now, let's get us a board that doesn't have any heatsink, so I can talk a bit more about the cooling situation on these. There we are, naked Rampage. As you can see, Northbridge with IHS, which is X48 typical. P chipsets don't have it. Also, X48 is really picky with the ambient temperature. It scales even with minuscule changes in ambient temperature. Like 5-degree change in ambient temperature can lead to at least 5 MHz more FSB. So I recommend, at the very least, changing the thermal paste that is on here by ASUS, because it's usually like a blob on half the heat spreader. It's terrible. If you're going to use the stock heatsink at all, which I don't really recommend, because ASUS built the heatsink in a way that has huge thermal delta between Northbridge and the fins of the heatsink. As you might know, let's get this one here. You can change this top part here. That's just screwed on here. And then you basically have a sandwich. You have, let's start with the die itself. You have Northbridge die, thermal paste. IHS, thermal paste, sheet of copper, solder, heat pipe, sheet of copper, well, solder in between again, thermal paste, aluminium, solder, heat pipe, fins. Horrible, absolutely horrible. That's why I like to use something completely different. I like to use massive copper coolers. And those are server coolers made for Socket 940. Now, I will leave a link to a listing where you can get those. They are complete bundles with a dual 940 motherboard, but they are super cheap, like 13 euros. Just keep in mind, you need some tools to basically make these heatsinks. They are not the way they come. Usually they have another tab here of copper plate and another tab on the bottom. So you need to cut those off, and you need to drill 2 holes in the base plate. It's a relatively thick copper, and tap them. I use M3 screws, and maybe if you ever have tapped copper, it's pretty annoying, because your tabs tend to get stuck, and you will take probably like half an hour tapping those 2 holes without breaking off the tabs. So if you're crafty enough, build yourself one of these, or get like a GPU heatsink, massive copper. Ideally, let's zoom in, one that doesn't have the fins soldered on, but made from the same material. Those are basically shaved fins. They get shaved from the side, like you use a wood plane, and then angled up. That would be the ideal situation, basically. Also, don't bother with the edges unless you feel unsafe running the Northbridge direct die. It's little IHS. If you do and you want ideal performance, delete the Northbridge. I'm going to show a clip from a previous video here where I show you how to delete this. Let's get a board to demonstrate the deleting. Here is a board that is not particularly alive. I took this because all of my good boards are already deleted. So let's find something, some razor blade here. Not razor blade, carpet knife blade with a dull edge on one side. You just want to push it from the edges inwards like this. Don't go too deep, like 5 millimeters maximum, because there are caps all around the die of the Northbridge. Come on. Again, do it on all 4 edges. Once you cut all the sides, you can usually flip them up. Let's see. I think there we are. Yes. Flip it up, and you can see the original foam paste underneath there. On this one, it looks like it came off a little bit already. I've seen ones where there's basically no thermal paste left, though that was probably my fault for putting the board in the dishwasher. And there is a little gap here where there's no silicone. At least you can see the bit of thermal paste here. So remove the IHS here. Gonski. If you run conventional thermal paste like MX5, KPX, Cryonaut, whatever. Just use good thermal paste between this and the IHS. That's a decent way of doing it if you're keeping it. And reglue it with some silicone. Or you can run liquid metal, in which case you should insulate those caps all around here. Just use some of plastic dip that you might use for insulating hardware you run on cold, or use Roman's fancy red nail polish, if you know what I mean. It's called Thermal Grizzly Shields or something. It's just nail polish, really fancy for extreme overclockers. And just use liquid metal between die and IHS, reglue, and use thermal paste between the IHS and the heatsink. Here you really don't need to use liquid metal. It won't profit you at all. Power density is so low once you are on that huge area here. I don't think it makes a difference. Just make sure the mount is nice and tight and squeezed down really well and the paste is spread evenly. Other cooling features about this board. VRMs. You can use either the stock heatsink or, like I do on some of my boards, cut up pieces of other mainboard heatsinks, or this is not even cut up, this is just a P5K or something, I don't know, heatsinks. They are not really completely necessary, they're just nice to have to feel safe. for most CPUs. If you're running quad cores, power-hungry quad cores, especially 65 nanometer, P3 stepping, so QX 6700, those things draw a lot of power, so with those you definitely want heatsinks on here. But if you run like E8400 or a dual cores, it's not necessary. Also memory, let's show this little two-phase VRM here. That's two phases with 4 low and 4 high sides, but 2 each. That thing never gets hot. Like, I shouldn't say never, but it doesn't get hot with the dual rank high bus, even at over 2 volts. So I don't bother with putting anything on here. You can just leave the stock heatsink if you want to feel comfortable. Now, let's get to the south bridge. Also not hugely important. On my main benching board I put the massive blue cooler on here. Basically just because I got that thing for free with some random bundle. But you can also use other south bridge coolers, like this one I took from Karma on Focus. G41 ASUS motherboard. Basically it's ASH10 anyways, it's the same chipset usually. More than enough. Just keep it cool so it doesn't die. That's about it for cooling, I think. So zoom out and move on. No, it's the wrong board. Let's get this one. These boards usually come with these capacitors here. They are basically, I think, 8 or 10 aluminum polymers in the same cases in parallel. And unfortunately they like to die a lot, as you can probably see. I recommend replacing all of them, even if just one is bad. Now, how likely is it that one of them is dead? I would say, from my experience, if you order a board, or manage to find it, you can't just order a Rampage Extreme. If you manage to find one, there's about 50% chance that at least one of them is dead or on its way out. So let's remove those. How do you know that they are on their way out? Basically, they short. Unfortunately, capacitors that fail closed circuit, which is really annoying. But you can test this easily. Zoom out. Here we go. If you have, measure on the north bridge. Here you see 13 ohms. North bridge resistance is dependent on your specific north bridge sample and also the temperature it has. So if this is cold, of course it is, it wasn't turned on recently. If it's cold and even the highest leakage, lowest ohm samples are around 7 ohms. This one is pretty high resistance, as you can see. If this would be under 5 ohms, this one is dead. Memory, if you put the ground probe on ground and measure, it is usually 195 ohms. Exactly. Well, pretty much exactly. So if this one is I don't know, double-digit ohms, so under 100 ohms, it's on its way out. CPU, great, here is already replaced. CPU, measure between 2 points of the capacitors around the socket. As long as it's not 10 ohms or less, it's fine. So that's what you need to know about those. Again, I recommend replacing them, and I'm going to show you with which kind of caps I replace them. Here we have one with the replaced caps. Is this the one with north bridge just put on here? There we go. Up. Zoom in. Let's turn it around. It's easier for me that way. you can see this is Panasonic SP cap. I use 2.5 volt, 470 microfarad, 3 milliohm ESR, so basically the best ones you can buy. I used to use 2 of those just in parallel. It works perfectly fine. But I managed to improve the ripple on the Northbridge. I just tested Northbridge, so I'm talking about Northbridge here. A bit by using also MLCCs. These bigger ones are 100 microfarad, 6.3 volt rated, 1206. You want X5R, but usually you don't get anything else anyways with MLCCs these days. Also 4 volt rated would do the job just fine. You're only pushing the Northbridge up to like 1.85, maybe 1.9 volts. The smaller ones are 47 microfarad, 0805 form factors, so the smaller MLCCs get, the better they get at filtering out high frequency. So it improves the ripple a bit, though the switching frequency of this is not that crazy high, but you also have to figure in like transients from the Northbridge itself switching, so it helps, definitely. With the stock caps, you'd be at around 10 to 15 millivolts under Super by 32 amp. With this setup, I never managed to get more than 5 millivolt ripple, so this is definitely a lot better than even one of those. Like, I measured my newest Rampage Extreme, so 9C batch that looked relatively little used, to measure ripple with the Fuji. So I gave it the best shot basically, and even then this solution will be better than well, as new as of one of those broadlizer caps as you can get in 2021 anyways. So if you feel comfortable, always replace them. Even if they're not dead, it's an improvement. And it actually, on some boards where they still were measuring fine, it got me extra 10 to 20 megahertz FSB depending on the board. Gains on Rampage Extreme in general are not as huge as even, like, all of the boards I had so far did at least 650 megahertz FSB in 32 amp, so Super by 32 amp. For memory, I used the exact same solution, as you can see. 3 times 100 microfarad, 3 times 47, 100 and 147, and the big SP cap. I didn't do any ripple testing on memory. I just assumed that the same solution as the Northbridge would be fine, and as long as the boards run 1000 megahertz, 675, 20 power level 6 with my Dominator GT sticks, I'm fine with it. On some of them I also test with the GTX2s to get to 1050, but this solution I never noticed like decrease in performance. I tested on one board something else that was ages ago. I actually managed to improve. Let's find the board. Here we go. This was before I mixed the MLCCs. This is just 10,000 100 microfarad MLCCs, and with this I noticed that I needed about 0.05 volts less for no, not 0.05, or is it? Yes, 0.05. Yes, for my 1000 megahertz profile. But then again, on this exact board, the Fujitsu, like, it wasn't dead, but I think it measured about 170 over 160 ohms, so it was on its way out. So take those results with a grain of salt. Anyways, it's not gonna get worse. That's the main point. Now let's talk about one of the last caps that is on here. That's the CPU one. Can't get in any closer. I don't like replacing these with SP caps. Mostly because it's in the middle of your mounting plate. If you have a solid mounting plate around here, it's going to be high centered and wobble a bit, even with the stock Fuji. So I try to replace them with something that is not as tall, so less wobble. So I just used a 600 microfarads plus 447 microfarads. You can also use two SP caps. They are not that tall, but it's not like all of this matters a whole lot. It's maybe I can't even confirm this, 10 or 20 megahertz more CPU clock in some situations, because you have a bunch of filtering already here, as you can see. It's like, what is this, 10 polymers already on here, so CPU filtering is pretty good. Also, maybe 16, maybe 8 phase, I haven't quite figured it out. It's like going from the VM controller into basically 8 doublers in a chip. And now what they really do, I didn't measure like each phase individually with oscilloscope to see if they actually like offset between two of them, or just basically modern ASUS style, 2 chokes, 4 FETs, 1 phase. So it's massive VRM. It won't have any problems even without this extra filtering on the back here for most cases. Now I think that's about it for capacitors. Those ones here usually don't fail like the flat ones do. They're usually pretty resilient, unless you toast them, of course. So don't bake your boards, please. Next thing I want to talk about is more of an actual mod than the previous parts, which is just improving like fails of ASUS. Or there we go. Zoom out a little bit. As you can see, I have a little voltmeter here and a potentiometer. Now this is a 20 kilo ohm. Just with this mod, it actually matters less what the total resistance of your potentiometer is, and like you don't use it as a usual volt mod where you have the potentiometer between your feedback pin and your ground pin. With this one, you have you have a pin of the LM324 here that goes to the middle pin of your potentiometer, and the outer pins go to 3.3 volt and ground. So basically what you're doing is varying the voltage on this pin between 0 and 3.3 volts. And with that voltage here, you're also varying the voltage of Vpll rail on the board between 0 and 3.3 volts. Now why would you want this? You can just set a PLL voltage in BIOS. Well, you can, but only from 1.5 volts upwards. And for most chips, that's perfectly fine, like a 65 nanometer stuff. You want higher Vpll actually. But with some Voltstale based chips, especially Pentium E5000 series and Core 2 E7000 series, you want lower VPLL because lowering the VPLL increases the FSB that you can run stably. So you need to mod it to get below 1.5 volts. Usually those chips need between 1.2 and 1.35 volts for ideal FSB clocking. Now, where do I hook up the other pins? Now, this is the middle pin of the potentiometer. This is just a display. Let's zoom in as far as we can go. There is, can't really see it. There is a little purple cable here, like just a wire with insulation. Soldered to ground, that's the ground side. You can put it on any ground in this area. I just used the screw ground here. On the back, you can also see, if you can see, is it focused? Very nice. you can see that I hooked up this little purple wire here to the top of this FET. This is 3.3 volt, which is also used as the input for Vpll. I also hooked up the red wire here, that's the supply wire for the voltmeter. The white wire is the measuring wire of the voltmeter, so I hooked it up to the positive side of this capacitor, which is Vpll itself. So this enables me to see Vpll here and set it manually with this. Well, it should get one of the fancier ones with the like the ones Elmar has, where you can just turn it by hand. But 20k here, you can use probably 10k and up would be a good idea, because you don't want to melt it basically. But the value isn't super specific. As long as you lift this, I should have mentioned that way before. This pin here, the third pin from the bottom, third pin from the bottom here is the one where you want to attach your wire. And you have to lift the pin from the board or cut the trace. Now, this is a bit of a finicky operation. As you can see, I completely failed on this board. I burned the PCI X1 slot here and also this cap. So I had to replace it. So please only do this if you feel confident in being able to lift up the pin. Or if you don't want to lift it up, you can cut the trace. There is a trace coming out from the third pin here on the pad. You can cut that and check afterwards if you have cut it properly. And then attach it. So just do it if you feel really confident in your soldering skills, and well, in your soldering skills if you lift it up especially, and if you're sort of confident you can fix the board in case you manage to destroy it by doing this, because you might. I already had the board once where someone attempted to do this mod and basically destroyed this chip. And is it this board? No, this one I destroyed myself, I think. And basically destroyed this LM324, and I had to replace it. Now, just keep that in mind. But if you're hunting for the top spots on both the 3M chips, that's basically the only way you're going to get there. Rampage Extreme with Vpll mod, because if you use Gigabyte, you don't have the memory efficiency that X48 can provide. Let's zoom out. I'm just going to... Heatsink came off. Those push pins are absolutely terrible. One more little thing. Some people might want to run Xeons on those boards. Let's show you. This specific one, I already cut out the two notches here, top and bottom. And on X48, only 3000 series work. So now you might ask yourself, why even bother at that point? Because 3000 series is 775 native chips anyways. Well, there's two chips. Well, yes, mostly two chips. Actually, mostly one chip, the L3014, single core Xeon, fastest single core chip if you can manage to find one. Absolutely amazing. And you want to run it on a Rampage Extreme instead of Gigabyte P45, which supports all the Xeons. In that case, you want to make sure that the CPU is properly supported. So look at your CPU-Z extension. No, not extension. Is it extension? I think it's extension. Where you see the instruction sets the CPU supports, like the middle tab of CPU-Z window. If it says SSE 4.1, everything works fine. If it doesn't, you need to add the microcode to BIOS. And I'm just going to leave a link to a modded BIOS in the description for Xeons, because some people manage to destroy their BIOSes doing that. So I'm just going to leave the one I used there, and it has worked for me perfectly well on two different boards so far, and should work for you as well, hopefully. I think that's about it. About these. There we go. Nice Rampage Extreme. I think that's about it. Those are all the things I do to my boards, and I hope it helps you overclock yours and hopefully get some records on them.